All right, today's notes is on linear regression. Linear regression is the same thing as line of best fit. You'll hear us say it interchangeably, both ways. So the definition says linear regression is a way to find the line of best fit that minimizes the distance between the line and all the data points. So this is really good when you have a lot of points that maybe not are not necessarily make up a perfectly straight line or curve. However, you do see kind of like an overall pattern, right? So for example, if you see all these dots right here, you would say like, oh, it looks like most of the dots are kind of doing the same thing. You would not say that like, oh, they're going up like this, right? It doesn't look like that at all. You would probably more than likely say, oh, it's going downwards, something like this. And in that case, that would be a pretty decent line of fit. Now, when you freehand it, unfortunately, you might make a little bit of a mistake. You might get kind of close. For example, what I'm saying is, even though you might think like, oh, it's going something like this, someone else might be like, no, I think it's a little bit lower, maybe something like this. And then someone else might have another idea saying, no, I actually think it's going more across like this. And who's right, who's wrong? It's kind of hard to tell just by looking at your eyes, right? So mathematically, there is a way of calculating the best line. It just takes a really long time to do by hand. So we're not going to go over exactly how to do it mathematically. What we are going to show you, however, is we're going to show you how to do it on your calculator. All right. And by your calculator, I mean by using Desmos. So before we do that, let's go ahead and I want you to go ahead and draw in what you expect your line of best fit to be. I'm going to go ahead and do the same thing. And I'm going to say, you know what? I think my line of best fit is something that kind of looks like this. That would be pretty darn close. Notice that most of the dots are somewhat close or exactly on the line. Obviously, I can't get all the dots to be on the line, but they're all pretty relatively close. Your line of best fit might be a little bit higher, might be a little bit lower, maybe a little bit more slanted, but it should look generally the same. All right. So what if I wanted to get like the best line of best fit? You're going to use Desmos. So let's go ahead and follow these steps. Number one, you're going to go to desmos.com/calculator. Number two, once you're there, you're going to hit the plus button on the top left. I'm going to show you exactly what that looks like in a little bit. You're going to click the table, and then you're going to enter all your data into the table. Once you're done entering the data, then on a new line, you're going to type y1 tilde mx1 plus b. I'm going to call that little squiggly thing tilde, thinking it's a tilde. I'm not exactly sure if it is. So if it's called something else, I'm so sorry. But I believe it is called the tilde, so we're going to call it the tilde. And then step 5, Desmos is going to generate a slope and a y-intercept. It's going to give you these numbers for you. You're going to write a new regression equation or a line of best fit using y equals mx plus b, but you're going to substitute what they told you the slope and the y-intercept is, okay? So let's go ahead and try that by show you how that works by using an example. It says the data in the table below gives the number of global social networks users since 2014 in billions. If X is the user since 2014 and Y is the number of users in billions, find the following. So here they give you the year, right? 0, 1, 2, 3, 4, 5, 6, 7, 8. Let's kind of annotate this a little bit before we actually jump into the actual problem, because I want you to understand what this is. When they say the year, that is your X. And X is the number of years since 2014. So this year 0 doesn't mean actually year 0. It means 0 years since 2014, which would be 2014. This year 1 represents 1 year since 2014. So if I add 1 to the 2014, this is actually 2015. Okay, that's what that 1 year represents. And then this 2 represents 2 years since 2014, which would actually be the year 2016. Okay, hopefully that made sense. And then as far as the y value over here, it says is the number of users in billions. So this is how many people have actually been on social media. So here they said in 2014, there were 2 billion users, okay? And then the next one would be 2.2 billion users in 2015 and so on and so forth. All right, so hopefully you understand what the table represents. And now what we're going to do is we're going to practice finding the line of best fit. So if you can, hopefully you can, you have an iPad or a Chromebook, I want you to go ahead and try to follow these steps. Go ahead and press pause on the video if you have to. But we're going to follow these steps right here. which is we're going to go to desmos.com/calculator, and we're going to do steps 1 through 5. Okay. So give me a minute to set up. I'm going to show you what it looks like here. There is Desmos. Notice that I already went to desmos.com/calculator. And step 1 was to go to the website. Step 2 was to hit the plus button. Step 3 is to hit table. Step 4 is to go ahead and click table. Oh, I forgot. I'm not done with step 3. I need to enter in all the data. So I'm going to type in on the X values. X value was 0, 1, 2. Now, Desmos is really smart. It already picked up a pattern, so it says 3. So I can go just hit enter. 4, 5, 6, 7, 8. Pretty nice, right? All right. Unfortunately for this next one, it's not going to detect a pattern because there really is no pattern. So I need to punch in these values one by one. So the first one was 2. Next one was 2.2. Next one was 2.31, followed by 2.73, 3.1, 3.51, 3.9, 4.26, and 4.59. Now, as I did this, I want you to notice what Desmo did. Desmo said, hey, all these green dots that we're going to place here, those are the information that you just put in here. So it actually plotted all my dots for me, okay? The other thing I want you to notice is if you were to make a best fit line, I would assume like most of this kind of looks like this. So when I draw my line of best fit, I would assume it looks something like this, right? And again, that's just a guess. But let's not guess. Let's actually fill it out. So notice that I hit a new line right here on line number 2. And step 4 says you're going to type that weird equation. You're going to type in y1. Now, when you type in y1, it'll automatically make that little one on the bottom. That's fine. Don't worry about it. Just keep going, okay? And then you're going to hit the tilde button. The tilde button is above the shift. So you're going to have to hit shift and then hit the tilde button. It's right next to your 1 exclamation point on the top row. And then you're going to type in the rest. The rest says mx1 plus b. When you do that, 2 things is going to happen. Number 1, it's going to draw in your actual line of best fit. So guys, this is the best fit line. Like you can't come up with one that has these distances when you add up these little distances to be smaller. Notice like all these distances are really, really tiny, right? And the other thing I want you to notice, it says, what are the parameters? They're telling you that, hey, if you want to get the line of best fit, your slope needs to be 0.341667, and your y-intercept needs to be 1.81111. Okay, don't worry about these numbers. They're not too important right now, but what is important is that you understand that these are your parameters. Okay, so what I'm going to do right now, you're not going to see me do it because I need to jot these down. I'm actually going to write down those numbers right now so I don't forget them. So we said that the slope needs to be, and I'm going to round because those numbers are like a lot of decimals. I'm going to write 0.342, and that my y-intercept needs to be 1.811. All right, let's show you what I just did. What I just did was I wrote this, right? According to Desmos, if I want the line of best fit or the regression equation, you're going to use this slope, you're going to use this y-intercept. So let's write it down. Let's see. I know that it's a line, so it's going to be y equals mx plus b. But I also know, according to my calculator, that my slope needs to be 0.342. That's going to go right here. And I also know that my b needs to be 1.811. I'm going to write that number right here. So my line of best fit is going to be y equals 0.342x, don't lose your x, plus your b, which is 1.811. And again, those numbers are my green number and my pink number. Now, why is it important that we know the line of best fit? Like, what's the big deal about it? Well, statisticians use this to predict what's going to happen in the future, right? So like notice that my data stops at 8 years since 2014, which would be 2022. I don't know what happened in 2023 or 2024. So let's look, in 2024, that's 10 years since 2014. If this trend continues, and it looks like it's doing a pretty good job of doing it, I can guess that the number of users on social media is going to be around 5.2 billion people, because I'm using my trend line, or my line of best fit, to extrapolate that information. Extrapolate means when you get information outside of your dots. I think interpolate, I don't know how to say it. It's something, interpolate. Sorry, guys, I'm failing you guys English wise, but if you get information within the dots, it's the I one. And when you get the information outside the ones, it's the one that has the EX, the extrapolate one. So yeah, we use this information to kind of predict what's going to happen in the future, or get missing information from stuff in the middle that maybe we didn't get. So that's exactly what we're going to do. Is we're going to estimate the number of users in 2020 if this 2027 if this information continued. Okay. So let's see. We're going to use our line of best fit. The first thing I want you to notice, though, is that they want the number of users in 2027. The number of this is the year, so that's my X value, right? Because they said that X was the number of users. I'm sorry, the number of years. So this is my X. However, I'm not going to plug in 2027 into my X right here, because your X has to be the number of years since 2014. So how many years has 2027 been since the year 2014? I need to figure out that number first before I start substituting any numbers. If I wanted to find out how many years it's been, I'm going to take that 2027 and subtract 2014. And I'm going to realize, like, oh, it's only been 13 years since 2014 if I want to compare it to the year 2027. This is going to be my X value. And this is where I'm going to substitute into my X value for my line of best fit. Because again, I'm using this line to predict what's going to happen in the future. So I'm going to go ahead and write Y equals, my equation is 0.342x plus 1.811. However, my X is now 13. So let's go ahead and substitute the 13. This is going to be Y equals 0.342 times 13 plus 1.811. I'm going to go ahead and use my calculator and get 0.342 times 13. That is Y equal to 4.446 plus 1.811 plus 1.811. And the answer I get is 6.257. This is your Y value. Remember that your Y is over here. It's the number of users. So I would expect to have 6.257 users. But remember that the users are in billions. So I can write something like, in the year 2027, I would expect there to be around 6.257 billion users. All right, so we were able to kind of make a prediction based off the previous information that we had. All right, let's take a look at number 3, because that one is a little bit different. It says, after how many years will there be 30 billion users? Notice that this time the 30 billion users, this is my Y value that they gave me. And so I'm still going to use the equation to come up with a prediction, but this time I'm going to be solving for my X because they already gave me the Y. So let's go ahead and, again, substitute. This is going to be Y equals 0.342x plus 1.811. But this time they gave me the Y value. So I'm going to substitute my 30 in here. I get 30 is equal to 0.342x plus 1.811. To solve for that x, we're going to go ahead and undo what's being done to the x. It's being multiplied by 0.342 and added by 1.811. So I'm going to subtract 1.811 on both sides first. This should give me an ugly decimal. Let's see, 30 minus 1.811, and I get 28.189 is equal to 0.342x. And I'm going to divide that number by 0.342. And I get that x is equal to 0.342, 82.423. Okay, so what is this telling me? This is telling me, remember, X is the number of years since 2014. So I can write a full sentence like in 82 years past 2014, I can expect 30 billion users. Now nobody speaks like that, right? Like nobody goes like, "Oh, in 82 years past 2014." So if the answer is 82.34, right? This is my answer. Now, if they said what year is that, right? Um, then we can go ahead and give the actual year number because I think that's probably more important. Again, the answer is 82 years, right? It's going to take eligibility after 82 years since 2014. But if you want to know like exactly what year that is, then you're going to say, all right, well, here's 2014, and I need to go 82 years past that. That's going to be in the year 2096. We can expect there to be around 30 billion users. All right, guys, that's all the information I have for you. If you have any questions, as always, please feel free to ask.